Throughout history, meteors and meteorites have had an enormous impact, no pun intended, okay, maybe a little pun intended, on the people of Earth, on events on Earth, and even the Earth itself. The impacts of meteors have affected our existence for millennia and will continue to affect us until the end of our reign on planet Earth. Indeed, a meteorite may be the cause of our demise. People have been worrying about cosmic collisions for a long time, but the field only gained scientific legitimacy in the 1980s when the extinction of the dinosaurs was pinned on a single strike of a comet or asteroid. First, before we begin this historical account, we need to have Meteors 101, or how to tell the difference between meteors and all their forms. A meteoroid is a rock in space, while asteroids are leftovers from the formation of our solar system about 4.6 billion years ago. Early on, the birth of the planet Jupiter prevented any other planetary bodies from forming in the gap between Mars and Jupiter, causing the small objects that were there to collide with each other and fragment into asteroids, which we can still see today. They can be anywhere from the size of a grain of sand to the size of a house and much larger. A meteor, on the other hand, is a meteorite that has begun burning up in the atmosphere, also known as a shooting star. A meteorite is a meteor that did not burn completely in the atmosphere and has landed on Earth. A very large meteoroid is also known as an asteroid. Most asteroids lie in the vast ring between the orbits of Mars and Jupiter. This main asteroid belt holds more than 200 asteroids larger than 60 miles, 100 kilometers in diameter. Scientists estimate the asteroid belt also contains more than 750,000 asteroids larger than 3/5 of a mile, or 1 kilometer, in diameter, and millions of smaller ones. The meteorite that killed the dinosaurs at the end of the Cretaceous period is believed to have landed on the Yucatan Peninsula, in today's Mexico, 65 million years ago. A 10-kilometer asteroid struck north of the Yucatan Peninsula, causing a global firestorm, then a cold snap, and finally a global warming that extinguished the dinosaurs. Molten rock from that impact would likely have landed up to 200 miles away from that impact site. Dust from that meteorite covered the Earth, blocking the sun's life-giving rays and making the Earth's surface cold, which is the same effect that nuclear winter would have. In 50,000 BC, a 150-foot wide iron-nickel meteorite hit Arizona and created this 0.75-mile-wide meteor crater. One of the most famous meteorite impacts in history happened during the morning of June 30th, 1908, in the Tunguska event in Siberia. The meteor actually exploded 3 to 6 miles above the Earth's surface, but did not leave a crater. In fact, it is still referred to as just an impact. It exploded with an estimated 10 to 20 megatons of TNT, which is over 1,000 times the strength of the Hiroshima nuclear bomb. If this meteor had been almost anywhere else in the world, there would have been at least one city destroyed, if not more. In 1972, the Great Daylight Fireball is witnessed blazing over the Rocky Mountains from the southwest United States to Canada. Scientists say it was an Earth-grazing meteoroid that passed within 35 miles of the Earth's surface. In 1997, astronomers projected in a report that a mile-wide asteroid known as 1997 XF11 had a chance of hitting the Earth in 2028. The report touched off a media tempest, but further observations reduced the chance of this type of collision to zero. This news came amid a spate of asteroid disaster flicks including Deep Impact and Armageddon, as well as the TV miniseries Asteroid. In 2004, an 885-foot-wide asteroid known as the 2004 MN4, later named Apophis, was initially given a 1 in 40 chance of hitting the Earth in 2029. That collision risk was ruled out relatively quickly, but it took years longer to analyze the risk posed by a possible later encounter in 2036. In 2008, asteroid 2008 TC3 exploded during atmospheric entry above Sudan's Nubian Desert. The event marked the first time that a near-Earth object impact was successfully predicted. Several hours in advance, the 2008 TC3 was 2 to 5 meters wide and broke up into fragments that were later recovered from the desert. In 2011, asteroid 2011 CQ1 made the closest ever flyby of Earth for a cataloged asteroid, passing within 3,400 miles of the Earth's surface. The asteroid was discovered just 16 hours before its super-close encounter, but because it was only a meter wide, it would have burned up in the atmosphere if it had been on a direct collision course towards the Earth. Again, in 2011, an asteroid the size of an aircraft carrier, the 2005 YU-55, sailed past Earth at a distance of 198,000 miles, which is closer than the orbit of the Moon. Earthlings marked the asteroid's passage with a barrage of picture-taking and heated discussions. On February 15, 2013, an asteroid slammed into the atmosphere over the Russian city of Chelyabinsk, creating a shockwave that injured 1,200 people. This space rock was thought to have measured about 65 feet or 20 meters when it entered the Earth's atmosphere. Ever since the formation of Earth about 4.5 billion years ago, asteroids and comets have routinely slammed into the planet. However, according to NASA, the most dangerous asteroids are extremely rare. Dozens of asteroids have been classified as potentially hazardous by the scientists who track them. Some of these, whose orbits come close enough to the Earth, could potentially be perturbed in the future and sent on a collision course with our planet. Scientists point out that if an asteroid is found to be on a collision course with Earth 30 or 40 years down the road, there will be time to react. Though the technology would have to be developed, there may be the possibility of exploding the object or diverting it. An asteroid capable of global disaster would have to be more than a quarter-mile wide. Researchers have estimated that such an impact would raise enough dust into the atmosphere to effectively create a nuclear winter. This would severely disrupt agriculture around the world and eventually lead to a new ice age, which would end life on Earth as we know it.